Meron tayo dito ang bagong sensor.
Ay, ano naman ba kayaan?
O ito. Sensor. Line tracking sensor. O, meron siyang pin header, ground, B+ signal. Ito, ano ito? Yan ay op amps. LM393. Comparator. May output LED, SMD, resistor, SMD, potentiometer, trim pot, 10, 10.3, 103, 10K, 391, 103, 10K, 391 ohms. Oh. At meron dito sa dulo na ano ito infrared transmitter, yung blue receiver, yung black R receiver, T transmitter nakalagay. May dalawang butas, lalagyan ng screw. PCB niya black. Yan.
Ay, ano na naman ang gagawin dyan?
Ay, testingin natin kung paano gumana itong sensor na ito. Ano ba ito? Dito galing yan. Teka. Sensor kit. Hindi masyado makita yun. Tracking sensor. Ito. Tracking sensor. Okay, tracking sensor ha. Line tracking sensor. Galing sa 37 sensor kit. Meron tayo dito power bank. Yun yung kanyang input pang charging. USB 5 volts. Out. At mga kable. USB cable. Jumper wires. At ang ating sensor.
Ay, ano naman ang gagawin mo dyan?
Testingin na natin ito. Kung siya ay gumagana. Kabit natin. Ground sa ground. G, ground. Itim, B+. Supply. Okay. Siyempre, sa USB 5 volts. Ayun na. 5 volts ang kanyang supply. Diba?
Oh, yan. Ano yan? Pagana yan.
Ah? Eh. Yan oh. Oh. Diba ito ay line tracking sensor? Ito. Tetestingin natin yung kulay itim at saka white. Ah. Okay. Pag dumaan siya sa black, yan o, may humarang na black color. Wala, di ba? Wala kang makikitang ilaw dyan. Walang output. Pero pag dumaan siya sa white, yun o. Umiilaw siya. Black, wala. White, umiilaw. So sa white lang siya nagto-turn on. Yun yung output LED, oh. Oh. Pag black, wala. White, umiilaw. Oh, yun ang line tracking sensor. So pag nadidetect niya yung white color, yun oh. Siya nag-o-on, on. Pag lumagpas sa white color, naging black, gumanon, lumihis, nawawala yung output. Nag-o-off. On, off. On, off. On, off. This is now the actual module tracking sensor. As you can see in figure 1, this is the actual module. Okay. The same with figure 1. And then we have this pin out of our LM393 comparator. So this is an op-amps comparator. Pin 1 is the output. Pin 2, inverting. Pin 3, non-inverting input. Pin 4, ground. We have two comparator inside the IC. So pin number 5 is the second comparator. That's why it's 2 non-inverting input, 2 inverting input of the second comparator, and then the output of the second comparator, then the supply voltage of the LM393 op-amps. So in this IC, we are only using one op-amps or comparator. We do not use this second comparator. Only pin number 1, 2, 3, 4, 8. And this is now from the reverse engineering of our actual module. This actual module, by tracing the connection, we arrived into this equivalent schematic diagram. So figure 3 is the schematic diagram of the tracking sensor module. As I've said, we are using only one op-amps or LM393 because the IC is composed of two comparators. But we're only using one comparator. So this is the symbol of an op-amps comparator. the inverting, pin number 2, and then the pin number 3, non-inverting, pin number 1, output, pin number 8, the supply voltage, and pin number 4, ground. We are using a single supply or B plus of 5 volts. So this is single supply. And then we have this infrared transmitter that is equivalent to the blue color LED. As you can see here, it's a blue color LED, looks like a blue color LED, and then the black is the receiver and connected this way. And then we also have the output. Output LED is here. That is the one that is turning on. And the initial state of the circuit. What is the initial state of the circuit? The initial state when we powering on this circuit is this output LED is off. There's no light for this LED. Off. What does it mean when the output of an op-amp is something look like this? The LED turns off. It only means that the output of the op-amp or the LM393 comparator is on. It is on. There's a current that flows out, that flows outward or from the output. There is a current that flow into the output, and the output is designated by the S or signal. There is a current that flows into the output into this direction, making this LED to turn off. Why is it turning off? Because the output of the op-amp is on. On, it means a high level of 1. Or a high level or on or high level. Making this LED to turn off. Making the LED to reverse bias. So the current will not flow from 5 volts. Current limiting resistor of 2K, and then the LED red, it will not turn on because the output of the op-amp is on, making this LED to turn off, reverse bias. Let us consider the operation of this transmitter. Connected the anode to the ground, cathode to the ground, and then anode to the current limiting 390 ohms resistor. The transmitter, color blue. Remember, this is color blue LED. And then the receiver is color black. The anode is connected to the ground with an cathode connected to the non-inverting pin and to the R3 10K and to the supply, while the transmitter is connected into 390, then to the supply of 5 volts. Therefore, what is the use of this transmitter and receiver into our circuit? It functions as a switch. Why is it working as a switch? Because the moment we put the power of 5 volts into the circuit, this transmitter will emit an infrared signal and going to be received by the receiver LED. Transmit, receive. As you can see here, if this is the transmitter, this is the transmitter, it emits a signal or infrared signal in the form of a light. And then when it detects a white color surface, white color, it bounces back the signal to the receiver. So there is a bouncing back of a signal back to the receiver. So if it detects a white color, it transmits the signal and bouncing back to the receiver. So it's switching on this LED. So that's why when we put a white color to the LED, it transmits infrared signal and then bouncing back to the receiver, and then we're going to be received by the receiver, switching this LED on. This is an infrared LED or some sort of a photodiode. Okay, photodiode. And then it is connected to the 10K resistor via pin number 3 of the op-amps. So therefore, it developed a voltage across this receiver, LED receiver or receiver. Receiver, black color. What is the voltage across the 10K and then into the LED? It depends. It depends on the distance of the obstruction of the white color paper we put in front of the LED. Supposedly, or let us assume that it detects, since this is some sort of voltage divider, or what if it divides into two voltage? Since we are using 5 volts, it means there is 2.5 volts flowing to the 10K, then another 2.5 volts flowing across this receiver. So the voltage across the non-inverting terminal is 2.5 volts. 2.5 volts. And then what happened to the another input, inverting input? We are using a potentiometer, or we call it a trim pot. A trim pot 1003 or 10K trim pot. Since the output is on, it means the inverting input is greater than the non-inverting input is greater than the inverting input. So since we are using a potentiometer, we can adjust the voltage here clockwise or upward, and producing a desired voltage. But initially, if we put the wiper of the potentiometer to the ground, it will produce a zero voltage, grounded. So the 2.5 volts develop across the voltage divider of the said receiver and the 10K is 2.5 volts greater than the inverting input 0 volts. What will happen to the output? It will turn on the output. This is now greater than the the inverting input. It has a logic level of 1 or high level. And then the inverting is a low level, 0 volts to the ground. Okay? Making the output to turn on. That's why there is no output, LED output into the output. If we're going to adjust the wiper to a desired voltage, Since this is a fixed voltage from the receiver and to the 10K of 2.5 volts. If we're going to adjust the potentiometer, which is called as a sensitivity, the sensitivity, if we're going to adjust that upward, for example, in this position, we now have this voltage divider from pin 3 to the wiper and then to the ground. What if we're going to adjust it into the middle position? It will create a voltage divider of, since we're using 5 volts, again we were getting a 2.5 volts to the voltage divider created by the adjusting the potentiometer. What if we're going to adjust it into making this a 3 volts by adjusting the potentiometer, making this a 3 volts? 3 volts now is greater than the 2.5 volts from the voltage divider of these two components. So, if this is greater, the inverting input is greater than the non-inverting input, it will have a logic level of 1 now. This is now 1. Since this is greater than the non-inverting, it becomes 0. The rules of the op-amp is if the inverting input is greater, has a greater voltage than the non-inverting, it will produce an output of 0. Remember before, this is 1. Now it becomes 0. 0 level means grounded. Because of adjusting the potentiometer, making this inverting input greater than the non-inverting input, it will produce an output of 0, inverted. That's why they call it inverting input. It inverts the signal from high level into a low level, making this 0. When this is 0, it means it is grounded. So the tendency of the current is to flow to the ground inside the op-amp. Therefore, we have now this circuit, 5 volts going to the current limiting 2K, then to the LED red, and then flows inside the op-amps, making this LED to turn on. It will now turning on. Before it is off. By adjusting the potentiometer, it will now turning on. There is an output. So it means that the output of the op-amp is a two-way, just like a two-way. It is capable of receiving and sending. Sending current, receiving current, transmitting current, receiving current, outputting current, inputting current. That is the output. It can be a two-way switch or a bulb or a way or a pathway of the current. Before it is outward, now it is inward, making this LED to turn on. So it means that we have now this output signal. Okay? Output signal, LED turns on. Why is it turning on? Because of the switch detecting a white color. While detecting a black color, it will not bounce back the signal. If the transmitter is transmitting a signal and detects a black color, if this is a black color, it will not bounce back the signal. So it will not be going to receive by the receiver. There is no output.